next, California State University, Northridge. By my calculations, is just a 15-minute drive from Pierce College. Go north and then east. CSUN has been a strong Pando Days contender before, and we're delighted to welcome a new CSUN team back. Our dear friend Lorraine Lundquist is the team lead. Their project is very future-oriented by definition with the next generation, teaching elementary school kids about composting and food waste. In California, it's a 6 million ton challenge with enormous potential. Lorraine, it's great to see you, and what a wonderful project you're developing with kids who will be inhabiting the future. Tell us more. Over to you.
Great. Okay, well, thank you everyone for having us. I'm excited for you to hear from my students. My name's Dr. Lorraine Lundquist, and my students are Jalen, Carlos, and Angel, Faith, and Zare. And I'm going to pass it over to Zare to get started.
Hi everyone, my name is Zare and I'm going to talk to you about our project. So our project's name is Composting to Reduce Organic Waste at Arminta Elementary School. So let's start with the project overview. The primary objective for this project is to establish a small-scale composting system on the school premises, providing educational opportunities while also fostering environmental consciousness among students. Furthermore, this project aims to reduce around 300 to 500 pounds of organic waste that were originally destined for landfills. This helps improve the school's sustainability efforts and simultaneously engages the school community in hands-on environmental education. So why is food waste a problem? When we waste food, it means we are throwing away food that could have been eaten by someone else who is hungry. In the States, most restaurants, supermarkets, and even schools usually don't allow food to be given to someone. They have to throw it away when it's not sold or used. When food goes to waste, it takes up space in landfills, makes them fill up faster. And it's also a greenhouse gas problem because when food rots in landfills, it releases a harmful gas called methane into the air, which can be bad for the environment.
So as we know, LAUSD produces a lot of waste throughout a single school year, throughout a week, and throughout a day. LAUSD serves around 650,000 meals every single day, and our average day waste and throw away $100,000 worth of waste each day. That equates to each meal costing around 1.5 cents. When it comes to composting, one of the biggest things that people use is uneaten leftover food. This works perfectly with LAUSD schools because they can't take back any food that is served, even if the food isn't touched. Once they serve the food, it must be either eaten or thrown away. LAUSD schools throw away around 1 ton of waste per school every single week. With there being around 600 schools currently in the district, that means LAUSD is throwing away around 600 tons of organic waste every single week. That is equivalent to around 200 elephants of waste a week being thrown away. And that is only coming from the meals that they serve. This doesn't include all of the other waste that is produced from these schools. That means there's 27,000 tons of food waste end up in the landfill each year from LAUSD alone, which is equivalent to around 61,000 cars on the road each year. With all that being said, LAUSD does have some recycling goals. They are trying to promote and spread awareness around recycling. They have stressed the importance of the phrase reduce, recycle, and rot, and nothing does that better than composting.
So how can we improve this? First, let's talk about the composting benefits. First of all, it reduces landfill waste. Compost diverts food scraps and yard trimmings from going to landfills. This decreases methane emissions. It also creates nutrient-rich soil. Compost transforms organic waste into nutrient-rich soil, usually referred to as black gold. This provides essential nutrients capable of restoring damaged soil while improving water holding capacity. It also improves soil erosion by providing essential nutrients to vegetation and improving their ability to develop strong root systems. It also reduces water usage because compost improves soil water retention capacity, reducing the need for irrigation. Finally, it mitigates climate change because organic waste in landfills decomposes anaerobically without oxygen, which leads to methane emissions. However, composting breaks down aerobically with oxygen, producing CO2, which is less potent than methane.
So this is where we're a little bit different. Commercial composters artificially heat up and aerate compost to speed up the decomposition process. What we are doing is we're allowing for the natural decomposition process, allowing for the natural cycle to occur. However, then this is where we're different. We do speed up the decomposition process by creating the conditions necessary for the suitable microbiology to flourish and naturally process the organic waste. So commercial composters, essentially, by heating up and aerating the compost, they essentially sterilize the soil, limiting the capacity of microbiology to flourish. So we've established certain steps that are kind of unique, where we layer in a certain way, and we add certain microbiology, creating the conditions necessary for them to breed and decompose all the material without creating any noticeable odor or animal problems.
The most common bug associated with composting is probably the earthworm. And while we do use many worms in the compost at the elementary school, as you'll be able to see in some of the pictures, a bug that we wanted to highlight is the black soldier fly, particularly the black soldier fly larva. So also called BSFL, they've been used to manage different types of organic waste, such as food waste and livestock manure. For instance, research shows that they've been used to reduce manure in commercial swine and poultry facilities because they reduce dry matter, pathogens, and odors that would come from the manure. And while we aren't exactly using manure in our compost, the functions of the BSFL are still important to breaking down the food scraps from the elementary school. One thing to note is that while BSFL perform a similar role to earthworms, they require less processing of the feedstock. They're less sensitive to their environment, such as the salinity of their food stock. And you can see in the picture on the right that next to the earthworms are the little larvae, which will eventually turn into black soldier flies. And here are a couple of pictures of the compost pile. As Carlos mentioned, we do the layering. Once the food waste is added to the pile, the plant waste is added on top and mixed in with the compost. In terms of their consumption habits, after the black soldier flies larvae digest and discharge undigested or waste material, the feedstock, the frass or excrement has been shown to increase the water extractable nitrogen content in organic materials, which can be utilized by vegetables for growth, which benefits the garden area, which we bring some of this composting over to. They also play a key role in providing nutrient value in organic and conventional agriculture. So according to a study on waste management of swine manure, approximately 45,000 larvae will consume 24 kilograms of swine manure in 14 days. And as the larvae developed, they reduced the manure by 50%, and they consume about 30% of their weight daily.
The next one, so this is one of the insects that have like a magical function with the compost. So I think we've all seen the Onesidae. I still cannot pronounce it properly, but so I think we've all seen those little insects that turn into a little ball, black ones. So this insect essentially reduces the heavy metals from soil, and it cleans the soil. We found multiple research that find that it significantly reduces the heavy metals which are necessary for a healthy soil. Next. And here we see we worked on lab results. We tested soil from another composting organization where we're applying the same processes as the ones that we are implementing in Arminta. And what we found, we compare it to regular garden soil. Regular soil that essentially just receives rainwater, no other nutritional value, compared to the compost that receives hundreds of pounds of organic waste on a monthly basis. And what we found was that, and also I would like to point, we inoculated the the compost at Arminta Elementary School with an existing active compost, the one that we tested the lab. So what we see here is that incredibly high levels of phosphorus, potassium, and nitrogen, which are the main requirement, the main elements in commercial compost. In commercial fertilizers. Additionally, we do see that the heavy metal content it's fascinating. We see that, for example, in lead, despite the fact that in the compost versus the natural soil, it's a little bit higher, considering that we are adding hundreds of pounds, between 300 and 400 pounds of organic waste per month, the level should be higher. And it's actually pretty close, standing at 10.32 parts per million versus the compost at 11.19 parts per million. So we see that it's a very, through processing of this organic waste, it's a very nutritious soil that comes out of it.
The following data is our compost collection in the last 2 months, October and November. As you may observe, there's only little data for October since this project is relatively new. But in the span of 2 months, we were able to collect 229 pounds of compost. Originally, if this food waste ends up in the landfill, it has a methane emission equivalent of 0.00123 metric tons. It seems like a small number, but let's note that this is just a data collection from a single school in a span of 2 months. And methane, as we all know, is 7 times more problematic than carbon dioxide. So basically, by composting, we could assume that we have avoided 0.1008 metric tons of carbon dioxide equivalent. We use the calculator provided by the stopwaste.com, which use EPA WARM tool as reference. Next slide. Now, let's look at a bigger picture. Our goal for this project is to collect at least 300 pounds of organic food waste from Arminta Elementary School each month. In a single school year, which is approximately 9 months, discounting breaks and holidays, we could gather about 2,700 pounds of compost per year. And that has a CO2 equivalent of 1.189 metric tons that could have been avoided by doing this project moving forward. Next. Now, to help you picture this number, 1.189 metric tons has an equivalent of greenhouse gas emissions and CO2 emissions from these comparatives. It's like driving a passenger vehicle for over 2,000 miles, or it's like consuming 82 gallons of gasoline in 1 year, or it may be equivalent to the weight of 11 refrigerators. Next. So if Arminta Elementary School has a projected compost collection of 2,700 pounds each year, just imagine how much compost can we gather if these elementary schools will also take part in this initiative. We want to focus on schools at the elementary level because they have the most number of students, and we could assume that they also produce a lot of organic food waste each year. But of course, the ideal is the whole LAUSD will adopt this method.
So for future developments, it is very exciting. The principal of the school, when there were other organizations that came over and they explained the composting, how it works, and he was a little bit nervous when we came and we explained that we were going to do something different. We are adding meats, we are adding dairy, we are adding citrics, which is what most composters are saying not to add. But with our processes, it's been very successful. So out of this, the principal is very excited. He is actually, he wants us to continue, but he also wants to introduce us to LAUSD because he's saying that every school should have this. Any school in the area that has a space should be doing this. Again, he's kind of surprised that despite the fact that we are adding meats, dairy, and citrics, there's no noticeable smell, which was the main concern from all the composters. And this is where the microbiology that we talked about is allowing us to achieve this. Additionally, we are working on some workshops, not only to educate the staff of the school, but we want to do workshops that educate the children as well as the parents so that parents can implement composting at home. And there's such a great interest in doing this. The reception has been great. And hopefully we can expand this to more schools in LAUSD to have the success that we've had in a very short time at Armenta Elementary School. Just so far, I'll just say this. We are right now, our goal was to process between 300 and 500 pounds of organic waste per month. But based on what we're seeing, it's possible that it's much more than that as well. So we're excited. Hopefully we can continue this and expand it to other schools. So these are our references. A lot of peer-reviewed research, of course, primarily on the insects and the schools, the waste. So here, if anyone wants to take some references, here they are.
Okay, yeah, Carlos and team, thank you all so much. I couldn't help but think while you're talking. I read a passage at length. I think he had it in a letter. John Adams, our second president, who wrote lovingly about compost and the feel of plunging his arms into a compost mound, and the feel of the compost and what have you. And I couldn't help but kind of flash on some of that. The depictions of composting here, that was going through my mind. But it's, and also, Anthony, you had mentioned in chat earlier about the interdisciplinary aspect of the Pierce project, and that was also going through my mind here, that just the interdisciplinary aspect of this. Anthony, since we started with you beforehand, George, let's start with you now for Q&A. What would you like to ask the CSUN team, or what observation would you like to make?
Yeah, first, thank you. Interesting presentation. We have composting here in our office at Bureau Happold, where we have maybe more traditional method with the worms. So now my mind's running. So I really like the idea about the scalability at the school, right? You have a common source which you know is relatively predictable. The method that you have, doesn't exclude the citrus and the dairy. So how do you bring this whole thing full circle, and where would you use the waste at a local level so that you could make it more of a circular economy? Where are your heads at for usage of the compost?
Look, based on the, like I said in the presentation, we used a compost that has been active for more than 2 years. So the results from that, if you see the lab results, it shows that it's incredibly nutritious. This particular compost comes from a food pantry, a nonprofit that runs a food pantry. So we are processing a lot of different types of waste, including a lot of junk food, to be honest with you. So when we inoculated I was expecting to have higher levels of lead and aluminum. But when we, as you mentioned, this is pretty predictable. What's the food source from a school? So by allowing this process to occur, we are essentially creating a product that can be used in other areas. So it's fantastic that I really do see it in the future where we process the entirety, or not the entirety, but 95% plus of the organic waste from the school in that tiny area that we have. So, and this is happening because of the microbiology in the compost. If you see, commercial composters like CalRecycle, they've spent $12 million preventing fires at their composting facilities. So, that means that it's dry. If you go in here and you dig a hole in the compost that we're doing, it has the right conditions. It's moist. It doesn't smell. It smells like trees. It's fantastic. And as you know, when we were working on this, we were asking ourselves, is like, there's no way this could light up. Even if you tried, this could not burn up because of the natural moisture of the the compost and the microbiology.
Yeah, maybe a kind of slightly different question then. It's like when you have this, like, someone I think referenced black gold, right? It's there. Do you want to use it at the school level? Are you bringing it into education programs about planting? Are you using it to maybe I'm taking some inspiration for the last Pando days about planters and stuff like that. How can you create that micro community that you don't have to like basically ship stuff around and transport it? Where are your heads at for end use?
It's just we do plan on using it at the school. In fact, the principal already opened the garden. We didn't start planting yet, but we do, because there's a lot of cement space. There's no green spaces. So we do plan on using it to kind of sprinkle around the garden. And if we do take this to a larger scale, we also would use it within the school instead of transporting it out, because that would be a smarter way, I think.
Yeah, thank you. That's what I was hoping. You're creating this like mini ecosystem where the kids can learn about planting, organic food, and have that resource locally, and then they can kind of have this whole circle. So yeah, thanks for clarifying that.
Anthony, do you have a question you want to bring in or observation?
Yeah, I'm going to probably jump into the weeds a little too far, but I'm actually kind of fascinated by the I'm going to put it in the chat, but basically like the process differentiation you're talking about, is this a novel process or is this something that's documented and is not commercially viable or necessary otherwise? Do you have any intent to produce some sort of like quantitative analysis to support whatever it is that the end goal for this work? And then finally, I guess, are there any like agricultural or chemical targets for your methods regarding like soil composition? And that being like, we all know, well, we don't all know, but some soils are better suited to particular plants versus others, trees, flower beds, sort of thing. Is this a process that is controllable enough where you can deliver those kinds of different products?
Who wants to take this? You want me to take it? So yeah, that's why we did the lab tests, right? So the lab test shows that it does have higher levels of lead, for example, which is something that's present in a lot of our junk food, which was natural for us to find that high level of lead. However, and you are correct, so certain soils are not good for certain plants. However, this compost would be good enough for mature trees. So what that means is it could be used for cover and for trees. And your other question was, what was your second question? You asked two questions.
I was only bringing up the line came out that this is a new or different process than what is commercially viable or available. And my question was basically like, okay, so if you're differentiating in a way that's meaningful, then there must be either some sort of analysis that supports that decision to differentiate, or you have a novel solution that's worth exploring.
Well, it is definitely worth exploring. Hopefully we can continue to expand. So, the results, despite the fact that they're new, they are showing that we need more data. That's the reality. We do need more data. But so far, allowing for we're putting together a lot, like several research together, right? This came up from putting together several research. The black soldier fly, the honest aid, which it's the kind of thing that's like I never paid attention to that, but then we started reading on the research done on them and how it cleans up heavy metals. I had no idea, right? So but also the layering, right? What we're doing in the layering is a little bit different. So the other compost that we're using, we are and it's been active, we are processing between 300 and 400 pounds per month. So we are expecting to do something similar here. And like I said, so far, we're hopeful and it's looking promising that we might be able to reduce the majority of the organic waste from the school. Mm-hmm. The problem is there's not much research specifically about this, which is promising and exciting, I think.
Yes. And that does kind of touch on the other point I was trying to make, like, what is your appetite for pursuing that level of rigor required to create, I guess, a long-term kind of process.
Faith, can you talk about our plans, our hopes for what we might do next?
Yeah, so in terms of what we have right now, again, like as we've mentioned before, a lot of this is are things that don't necessarily have like as much research about, so we're hoping to be able to get that information ourselves. But just off the top of my head, we're hoping that because there are other things that we'll be composting, that if they show to be things that are reasonable to compost and are helpful and are able to continue adding nutrients and things like that, that it would be able to kind of have a broader range of what we can compost and what people in general can compost, because in the research that we had done before, many of the common things that that were discussed about why certain things weren't composted was because of things such as pests or smells, or different types of pathogens and things like that. And so we're hoping to look into it, but at least from what we can tell so far, it doesn't, we haven't really had that many pests. I don't know if it's necessarily because of depending on the location or how we've been taking care of it, there hasn't been much of a smell either. As Carlos mentioned, it just kind of smells like dirt and plants and things like that. So we're hoping that those kinds of things, while we've been working on this compost, we've seen it with our eyes, and also beginning to test that as well with the past couple of months of data that we've had so far, in the future, continuing on seeing what can come from that.
Overall, we think it has a lot of potential. I mean, I used to work for LAUSD, and they do waste a lot, especially when it comes with food. Whether that's from nutrition, lunch, recess, after school, they do produce a lot of waste. So if we can find a way to use that waste to kind of serve the students there and kind of serve as an educational purpose, I think we think it's definitely worth researching into and kind of trying to spread through our LAUSD.
Yeah, Faith, you touched on something, and I was thinking of that construction. Is there a minimum perforation or a minimum you need for airflow and light, and then a kind of match you need to make sure you don't have any vermin trying to get in there? Is that something you've been investigating?
Yeah, that's definitely something we would keep in mind. Off the top of my head, I wouldn't know exact calculations, but what we do have right now is there is a general gated area around the compost, and where we put the food waste. It is also in a courtyard in the elementary school, where I would assume that possibly because of the location that it is on the campus, that it's less likely to be dug through. But so far, it doesn't seem like we've been having any problems like that.
Okay. Well, what a fascinating project. Thank you all. It's I have myself been into composting, and but I learned a great deal, and it opened up my imagination in a whole new way. That's it for today. At this point in the Premier schedule, we've seen 6 of 16 projects developed for the 2023 Pando Day season. We have 10 more to go. Up next, join us tomorrow at 2:30 for Mount St. Mary's presentation, and then at 3 o'clock for USC's. Both will be fascinating. Thank you so much again to George and Anthony, our expert panel from Borough Happold. Many thanks to all the Pando Days colleges and universities that have dedicated full courses, studios, or labs to help LA County meet its sustainability goals. Pando Days was conceived in collaboration with LA's Chief Sustainability Officer Task Force and is in partnership with the county's Chief Sustainability Office. Pando Days is made possible by the support of our sponsors and by the generous contributions from individuals across the Southland and beyond. Thank you for joining with us. Enjoy your evening, and don't forget to compost.